of all of your guys' labs grading. So my goal is to finish off grading those today so I can push those back to you guys. Lab or quiz one seemed to go pretty well, at least from a technical standpoint. I think out of the 300 in the course, we only had about 7 who just plain did not do the quiz. So if any of that is you guys, I'll be following up with you probably today on that, because as a reminder, we don't have unlike the labs, there's no general policy of, hey, if you do the quiz a day late, you get this penalty. It's a quiz, it's a test, right? So you need to let me know ahead of time if you need to do a makeup. If you just skip it, then I need a good reason of why you decided you were too good to hang out for my exam. And while on this very first quiz, I might be somewhat sympathetic and open up some makeups, my sympathy is going to drop pretty quickly over the next quizzes if you guys continue to skip them. And I keep saying you guys in the larger 356 case. If this doesn't apply to any of you, then congratulations, you're all perfect. The big things we have on the horizon due is next Wednesday, homework 6 through 8 and lab 3 are both due. So make sure you are starting to work on that if you can. And then quiz 2 opens up next Wednesday, which I know part of you is like, oh my gosh, we're just talking about quiz 1 and we're already talking about quiz 2. And yes, they are close, but that is by design. We have more quizzes this semester than we had last semester. But that's not just because I was like, oh, it was too easy, let's make it harder because I'm evil. I'll be honest, I'm a little evil. That's why I decided to become a math teacher. But in general, this was what the cadets said they wanted, because we made more of them, but we made them fewer points, but more regular. So it was kind of check-ins. So you had more low threat opportunities to kind of see how you were going along there. So it wasn't just no quiz, no test, and then one big GR that covered everything, and it was all or nothing, right? There's a bunch of opportunities to get those points and check in, see how you're doing, so that when the big GR does come along, it does not feel like as big of a shock or surprise. And so as we get to the end of the semester, if that's not how it works and you go, no, I would have rather just having 1 or 2, then let me know, because I'm trying to make the exam for you guys. It's easier for me to make fewer tests, and so I'd rather just do nothing during the entire semester and just give you one final at the end, but I would lose a lot more of you that way. So I'm trying to make it more reasonable and work more to learning. I think those are my big points. Does anyone have any admin questions on what we have been doing, are doing, or what we're about to do? Anything coming up?
Are there going to be any more videos like our tutorials posted?
Yes.
Sometimes for Lab 3?
Yes, sure. I will definitely put some together with the quiz and everything. I've been kind of jumping back and forth between EI and didn't have any new, but I will be trying to make some today. I was actually considering, I'm always interested in what's useful to you guys, because I don't want to make something that no one looks at, contrary to popular belief. I don't like the sound of my own voice that much. I'm pretty full of myself, but even I have my limits. So with that in mind, I appreciate it anytime someone, I try to make videos based on what I'm seeing in the lab discussion, but if there's ever a function or a concept or an example that someone would like to see a video of, just send me a direct message and say, hey, could you do a video on this? And I will be happy to do it. I was actually, if there's interest in it, I was considering adding a channel on the All Students of our tutorial video requests, where people could just put in requests, and then I will look at them and, depending on how they get upvoted or not, start making videos on that. But in the meantime, I will just try to make videos around the functions. But please push those to me, because I'd rather it be what you guys want to see than what I think you want to see. I also had a suggestion from first period that I might do this week. I know I can't find a time when everyone is available, so I'll try to do it more regularly, but someone floated the idea that I thought was good of maybe once a week hosting when I'm not teaching class kind of a R Studio AMA where I just have a meeting where it's open for 1 to 2 hours where I say, hey, I'm just online here with my R open. Come in and ask me either a specific question or say, hey, here's a function I thought I should be able to do. How would I do it in R? Whether it's people trying to catch up to what we're doing or people who are feeling good but want to learn a few more things and tricks in R to go through there. So if there's any interest in that, also send me some direct messages and tell me based on your guys' schedule what would be a good time to do it. I try to keep it during the day, but I know you guys have classes, so if it's only once a week or every other week, I don't mind doing like an AMA in the evening or something when you're out of classes. Yeah, Jenna, what do you got?
Sir, I was just wondering about the quiz. Sorry, you may have said this, but is it open to view? Like, can we see what we got right and wrong?
Sure. So the short version is it is open, not in a way where you can just go on there and look at that. I have access. You can see your score, obviously, but you can't see the right and wrong answers. And so I've already had a couple of people who want to do it. So if you want to look at that, just send me a message. And what I'll do is jump online with you and we can open up your particular instance of the quiz, and we can look at which ones you got right, which ones you got wrong, and see why they're. So if anyone ever wants to do it with a quiz or a GR, I can do that, but it has to be on an individual basis. A, because we don't just release them open, and B, each person there's a pool of questions, and different people get different questions. And different multiple choices. So I need to open up your particular instance, and then we can screen share it, and I can show you what the right answer, wrong answer was, and why. So if you want to do that, just send me an invite of what time, and we can, depending on whether it's a quiz or a GR, it's like 5 to 10 minutes that you do. Or if you just want to know what question you got wrong, send me a message, and I can say, here's the one you got wrong. And then if you want to talk about why, we can do it. But if you were just curious, you're like, hey, I know I got a 90, which one did I miss? I can tell you that if that's all you want to know. But I need to know who it is because it's different for each person.
Gotcha. Thank you, sir.
All right, cool beans. Anything else? Someone made fun of me the other day, says I use the phrase cool beans too much. I was about to argue with them, but I then realized that there are certain things I use too much because I was writing a text to someone the other day, and I wrote the letter A, and it auto-completed to awesome sauce. So apparently I used that word way too much. I guess it could be worse as what it auto-completes, but I acknowledge that I am a walking cliche. And also a lot of my stuff, like I said, comes down to that I have 3 children that I've had to edit myself. So every now and then I will say things that do. I think I told you guys in our house, one of the curse words my wife and I use is grumpy muffins, because when my son was about 5, he was playing the original Mario Brothers, and the first time he saw a Goomba, he thought the Goombas looked like a grumpy muffin. And so that was something we started to use as like when we wanted to curse in our house around the kids. And it got so regular that then I forgot I was using it in real life. And I remember one of the best double takes I ever got was I was deployed talking to an Army major as a captain, and he said something. I was like, oh, grumpy muffins. And he started to walk away, and he looked around and goes, did you just say grumpy muffins? What the F does that mean? And then I had to explain it to him, and he goes, well, I'd make fun of you. He's like, but people curse around me all the time, and it never makes me stop. He's like, grumpy muffins made me stop, so I guess it has more impact. All right. If anyone's got any other questions, jump in. Otherwise, I'm going to go through today's. Today's is kind of an extension of what we did yesterday, or not yesterday, last time we were together, Tuesday. So it is like so many things we do in this class, it is the same but different, right? So everything of how we explained it, we're going to talk about continuous random variables today, and we introduced kind of random variables in general and discrete ones. And so we're just going to really talk. It's not so much we are introducing a whole new concept. We're saying, still talking about random variables, here's how continuous variables are different. So this is going to be a theme that we have this whole semester, where as we have a new lesson, I'm not saying, okay, format a whole new section in your brain and memorize all of this. What's more important is saying, hey, don't use up extra brain space. Remember how we learned this one thing? Okay, here is a slightly different version of it. Just understand how it's different. That's what we're going to do today. So it shouldn't take too long. If you got questions, ask them. And if it takes the whole period, that's fine. But my hope is that we can finished with about 20 minutes left in class that I want to be able to give back to you guys that we can work on lab 3 while we're in here and get any questions you have out on that. Okay, so interrupt me if you got questions, but let's go through continuous random variables. So we talked last time about the idea of discrete random variables, right? We said, hey, maybe I've got this random variable x and it can be 1, 2, or 3, but then I'm saying they're not equal probabilities. I get 1 half the time, I get 2 maybe a fifth of the time, and I get 3 30% of the time, right? And so that is the definition of a discrete random variable, because there's a discrete number of options, which doesn't mean that it is, in this case, I have a finite, but I could have, as we showed with an infinite-sided dice, it just means that they are countable, right? And I could talk about the probability of, I can't say what x is because it's a random variable, but I could say the probability that x is 1 is 50%. Or I could say the probability that x is strictly less than 3 is 70%, right? I could, if I wrote an actual equal sign there, I could write those type of statements, right? Well, if we want to formalize the probability of a discrete random variable, I could talk about, we hinted at this before, but I could talk about it as a probability mass function. That's what PMF stands for. It's the probability function for a discrete random variable. So, for example, this one here would be the probability mass function for rolling a die, right? And I could call it f of x, right? And it's basically f of x equals 1, 6 for the values 1, 2, 3, 4, 5, and 6, right? If I really wanted to explicitly write it, it would be f of x equals, and I would say, 1, 6 for x equal 1, 2, 3, 4, 5, 6, and then I would say 0 everywhere else. Because the probability is masked at these areas. If I want to say what's the probability of 3, I would say f of 3 equals 1, 6. What's the probability of 2.1? It's 0, because at 2.1 the probability is 0, right? And so sorry, I didn't mean to erase that. In a probability mass function, the function, you give me an event and it gives me back the probability, right? Now, I kind of drew these ones on the bottom poorly because I have words or letters, but like I told you guys before, random variables have to be represented by numbers. So yes, maybe this is the probability of a CGO and FGO and GO, but I need to give these numbers of saying that's 1, 2, 3. Maybe over here I do GPA and say that's a 0, 1, 2, 3, 4. It's okay that they mean other things, but if I'm going to talk about them as a random variable, I have to assign it to a number, so that over here I can say the probability of 2 equals about 0.75. And afterwards, I can say, well, that's the same as finding the probability of C. But if I want to talk about it as a random variable, I have to give it numbers. But this is a way of describing the probability of discrete random variables with a function, and we call that a probability mass function, because the probability is masked at each one of those discrete options and 0 everywhere else. Any questions about that and what these pictures mean and how a PMF would work? Okay, now you may have noticed that every time I talked here, I kept emphasizing M or mass, because I want to differentiate from what we're about to talk about of continuous random variables, which with a continuous random variable, we have a PDF, which is a probability density function, right? And so we use probability density functions when we are talking about a continuous random variable. So a continuous random variable is something like this up at the top, right? What's the height of a male, right? And unlike rolling a dice where my options are 1, 2, 3, 4, 5, 6, here, a male could be 72 inches, could be 73 inches, but it could also be 72.5, or 72.58, or 72.589999, right? The main difference here is that there is a uncountably infinite number of options in between them because it is continuous. It can be everything, right? When we talked about a die rolling, we said I could have a die with an infinite number of sides, and that's still discrete because I have a countable number of options. 1, 2, 3, 4, 5, 6, 7, 8, 9. It can just keep on going to infinity. But it's discrete because I have 5 as a possibility, I have 6 as a possibility, but there's no possibilities in between them. For a continuous, I can be 70 tall, I can be 71 tall, but I can also be anything in between, right? This is that weird concept of both options are infinite, but one is a bigger infinity because it is uncountably infinite. If you've never run into that concept before, I always think it's interesting to say, well, how many whole numbers are there? There's an infinite number of whole numbers. How many fractional numbers are there? Well, there's an infinite number of fractional numbers. And then I say, okay, well, how many whole numbers are there between 1 and 10? There's 10. Then I say, how many fractional numbers are there between 1 and 10? There's an infinite, right? So obviously that second infinity is a bigger infinity because I have an infinite packed in a tighter space, right? Which is just kind of a weird concept to talk about if you guys ever want to. But the point is the result of that is that I can no longer use a PMF because it doesn't make sense to talk about the probability of one thing, right? When we're looking at this idea of the dice, and I say, what is the probability of 2? I can just go up here and say, hey, it's 1/6, right? When I'm looking at what is the probability of someone being 72 inches tall, well, there is an uncountably infinite number of options. And as a result, the probability of any one thing happening goes to 0. I can't talk about the probability of being 72 inches because there are such an uncountably infinite number of options. The probability of any one exact number happening is 0. And so I can talk about it. It's just the probability is 0. But what we normally talk about is what is the probability of a range. So what I can say is I can ask a question of what is the probability that someone is taller than 72 inches? What's the probability that the continuous random variable h is greater than 72? And as you can probably tell from the picture, the way I do that is I go, well, there's 72, and to find the probability that someone is bigger than that, it is this area under here, which I know you guys are all muted, so I can't hear your thunderous applause and cheering. I know you guys were all really concerned that once you left Calc 2, that you weren't going to get to do integration anymore. But don't worry, now that you're in 356, you've got another opportunity to do integration because that is how we find the probability of ranges of continuous random variables. It is the area under the probability density function for that range of values. Now, that being said, before you drop my class, I will tell you that this is not a Calc 2 class, so we're not going to do complicated integrals. Most of the time, either we're going to do a very specific function where it's already built into R, and I'm just going to tell you the function, and you just type it in, and it gives you the number, or 95% of the time outside of that, if it's something you have to calculate, I'm going to give you a real simple straight line probability density function that you don't even need integration to use. You could literally just use it by finding the area of triangles or squares in there. So the intent is not for you to have to open up your books and remember how to do integration by parts or any of that. We're not going to do that. It's more important that I want you to understand the concept of why a continuous random variable requires a PDF instead of a PMF, and how we calculate the probabilities there as a area rather than a height. Because the probability density function, I can still up here say, if this is f of x over here, I can talk about what is f of 68, right? If I go up here and say that is the probability density of 68, but it's not the probability, right? So when I go over here, the mother of everything, if I go here, the f of 2 is literally, that value is the probability of getting a 2. When I go over here, the value of the actual function in a PDF is not a probability. it's the density, which we usually that doesn't have as much meaning, but in general, what it means is the probability is packed more densely there. If I go just a little bit around 68, say what's the probability that someone is between 67 and 69, I'm going to get a relatively high probability because the probability is packed more densely there than as if I said, hey, what's the probability between 58 and 60? Well, the value of the function is very low there, so probability is not packed densely there, and as a result, probabilities of a range around that are going to be low as well. Any questions about the similarities and differences between a continuous random variable versus its discrete brother, and how we calculate the probabilities, at least in concept here, and how it differs from discrete random variables? Awesome. Okay, so let's look at an example. So here is a PDF that I just made up. So this is a probability density function for a continuous random variable x, and I'm saying here is its probability density function, which I could draw it, and it looks like this. So let me ask just open question. Actually, forget open questions. Let's ask specific questions. Kyler, you online? Did I say your name right?
Yes, sir.
If you had to guess, and it's all right if you don't know, what do you think is the area of this entire area under the curve?
1.
Yeah, he's exactly right. 1, right? Because area under this curve represents probability. So the entire area has to equal 1 in the same way that when we looked at this dice example, all these heights have to add up to 1 because the total probability has to sum to 1, right? Now, when I define this PDF up here, I actually didn't define it completely correctly because I should have said, something like for x between 0 and 2, right? Because this function here continues to go down this way, right? But after 2, it no longer is valid. 1, because I can't have a negative because then that gives me the possibility of getting negative probability, which doesn't work. But I run into other problems as well, right? So you can have a PDF, just like we had a PMF, where the probability mass function for the dice only made sense at 1, 2, 3, 4, 5, 6, and it was 0 everywhere else. Here, I've got a probability mass function where I say, hey, it makes sense for 0 to 2, and then it's just 0 everywhere else, right? I have to make that definition. But now I can talk about what is the probability of the random variable being between different things. So I can say, hey, what is the probability that it is between 6 and 9, right? Which means this x-axis are my possible values for my random variable. I mean, not this up here, but in general, the place I find possible values is the x-axis. So if I say, what is the probability that it is somewhere between 6 and 9? Well, graphically, it is that area. And I know I drew this in R, but I always suggest when you're faced with a problem like this, draw a bad picture, right? Yes, this was with R, but I could just easily go, okay, well, this is something, and it's when I put in 0 for x, it's 0, and it's cubic, so it's going to go something like that up and then back down. So I don't know where it goes, but I want to go from 6 to 0.9, and so what I want is, I know it's the area, and it's that area, right? That picture is not going to help me actually find out what the probability is, but it's going to help me understand in my head, okay, yeah, it's the function, and I need to find the area, which means I need to integrate it from 0.6 to 0.9. So then when you solve it, you can say, here's what I want, the picture looked like that, and so there's the integral to solve it, right? Drawing a bad picture really helps get your mind straight of what you're doing to figure out how you're going to solve it. In the same way we did that kind of with Venn diagrams when we introduced probability. Because once we have that set up, then it's just an issue of solving, right? This is a little harder of a problem than I would normally ask you to solve, but it's still not that hard. It's just a basic polynomial. Do the integral, put the bounds, solve it out, and I get 0.1578, meaning it's about 16% probability that x is between 0.6 and 0.9. And again, even with a bad picture, I can look at that and go, yeah, that's about 16%. Because if I over here had got an answer of like 0.99, I'd be like, whoa, that can't be right. Like my picture is bad, but that doesn't seem like it should be 99% of all that area underneath it. And so it would, maybe it's right, but at least it has that sanity check of like, okay, then either this answer is wrong or my picture is way off, and trying to figure out what it is. So look for those little sanity checks where you can, to make sure that you're on that right track. Any question on how this PDF was represented and how we used it to find the probability of a particular range? Okay. Now, when we introduced the idea of random variables on Monday, we said, well, I can't tell you, by definition, it's random, so I can't tell you what x equals, but I can tell you that the probability of x equaling certain things, or now that we have continuous, the probability of it equaling certain ranges. But then we did say I can talk about aspects of it that describe kind of how the random variable acts. So I could tell you, the expected value of the random, that tells me on average what I can expect out of the random variable. Or I could tell you the variance of the random variable, which is a measure of how spread out it is, right? And so we can do all those same things for a continuous random variable, but like I said before, it is the same but different, right? And so it is, rather than set a whole part of your brain aside to do continuous, I think it's more important to just understand how the process is the same, but the execution is slightly different, right? So let's talk about expected value. And on the top, we're going to calculate the expected value for a discrete random variable x. And on the bottom, we're going to do it for a continuous random variable x, right? So for the discrete, we started off and said, well, for the expected value, we're going to sum up over all the possible values of x. Same thing for continuous, only instead of summing up, we're in the continuous world now. So now we're integrating over all possible x. And I want to be clear, someone brought this up in the last class, one of my last sections, which was good. Well, my version here works most of the time. It's not actually technically accurate. I should make changes because I said from the minimum x to the maximum x, right? Which on a version like this here, that works because the minimum possible x is here and the maximum possible x is there. So if I want to add up over all possible x's, then I integrate from the minimum to the maximum. That said, there are possibilities where I could have a continuous random variable that looks something like this, right? And where this and this add up to a full probability of 1, and this is just a range that you're not allowed to use for some reason, right? So this would be my minimum x, and this would be my maximum x. And I don't want to integrate over that entire range because this part doesn't count right here, right? So rather than min to max, how I have here, it would be over the entire range, which here would be integrate from here to here, then skip the next part, and then integrate from here to here. So usually it's in a continuous version like this, but it is possible that this happens sometime. And so I just wanted to make sure before you committed this to memory that that is not technically true. It shouldn't be integrate from min to max. It should just be integrate over the range of possible values of x. Does that make sense? Does anyone need any clarification on what that is? I just wanted to make sure I was giving you guys the full truth and not just here's the version that works 95% of the time. And then when you come into the 5%, be like, no, but Colonel Richards said min to max. Well, he lied. Does that make sense? Any questions on that?
Sir, can you say that again just slightly differently? I think I know what
Sure.
you're saying, but I'm a little confused.
Sure. So here, the idea is when we do this and we do this, what we're saying is my cursor's got on my zone. What I'm saying is we want to add up over all possible values of x, right? And so the way I wrote this here shouldn't really say min and max. It should just be something that says something like integrate over all possible, if I could write, x, because in general, most of the time you're going to see PDFs like this, where the PDF starts here, ends here, and here is the whole region, right? So if I want to here the minimum x is 0, the maximum x is 2, and so if I integrate from the min to the max, then that hits all possible values of x. However, there are some rare instances where you have a weird PDF that rather than being just the possible x's are all continuous, you might have something like, you know, this, right? Where I have something like this where x can be, maybe this is 1, 2, 3, 4. And x can be anything between 1 and 2, and it can be anything between 3 and 4, but it simply can't be anything between 2 and 3. So in this case, all possible x's would be anything from 1 to 2 and anything from 3 to 4. And so in that version, my min to max wouldn't actually be accurate anymore because the min is 1 and the max is 4. And if I just integrate from 1 to 4, then I am including 2 to 3, which isn't possible. And so what I should really be doing is integrating from 1 to 2 and then adding the integral from 3 to 4. And so that's all I'm saying, is that this should really say integrate over all possible ranges from x instead of saying from the min to the max, because sometimes the min to the max includes some values that shouldn't be included. Does that answer? Is that a better way, or is that still okay? Excellent.
Yes, sir. That makes sense now. Thank you.
This is rare, but it happens sometimes, and so I didn't want you to think that this was some universal truth. That was just me oversimplifying and realizing it when someone pointed it out. Okay, so once we have that, then the next thing is that we, for all the possible values of x, we then take each possible x you can get. That's how we did it in discrete. We're still doing the same thing in continuous. Then in the discrete, we said, and for each possible value of x, multiply it by the probability of getting x, right? And we do the same thing in the continuous. It's just that for the continuous, this is the probability of getting x, right? Because we talked about that the probability of getting a specific number goes to 0, and so it is 0. But the f of x is the PDF, and so that's the height of it. And then I've got to multiply it by that little d of x, if you remember that infinitesimal. So this right here is an infinitely thin sliver of probability. That is the probability of equaling x, which is the same we did up here. It's just we had to modify it to be able to do it for an integral over all the continuous, uncountably infinite possibilities for x. Once we have that set up, then we can just solve it, right? This is the plugging in the equations from here. I can say the possibilities are from 0 to 2. I solve it, and then I get 1.2, which if I look at over here, it kind of passes the common sense check. That looks like what I would expect, right? If this was over here ended up to be 1.9, I would go, that doesn't make sense, right? Because it seems like there's a way bigger probability of getting stuff less than that than there is above that. So why am I expecting to get such a high number on average? And then you go back and go, oh, I did the math wrong, right? So use that common sense check, okay? Any questions on how we calculated expected value here and how the processes are the same? We're just translating it into the continuous world. And I didn't calculate the variance here, but I encourage you to do it on your own, because you could calculate the variance of a continuous random variable in the same way, where you look at how we did it on discrete and then just translate it down into an integral version for the continuous. And so I encourage you to try that out. And if you get stuck on it, let me know. Okay. We got about just under 20 minutes left. And so as promised, I would like to spend the rest of the time working on lab. So I will turn my mic off until someone asks me something. But if you are already working on lab 3, then just use this 20 minutes. Assume this would be the part where we're in class, where you guys are all working and I'm just walking around and see. Just get 20 minutes ahead of your lab. If you have not downloaded it yet, use this time to jump on, download it, and start reading through, right? And if you don't want to actually, you're like, I don't have enough time to actually get ahead, take this time to download it and start reading through the scenario and the questions and see, does each question at least make sense? If you get to a question where you say, I don't understand what this question is asking, or I don't know how I would get started on this, use this time to turn on the mic and say, hey, sir, can you kind of give us I'm not sure where to start on 12 or do this. So use this time to ask me so that when you leave, you at least feel comfortable that you can start on working through the weekend. Because I'll be available tomorrow, but then I'll be off during the weekend, and then I'll be back on Monday for any questions. So I ask you guys to open that up. Like I said, I'm going to turn my mic off, but as soon as I see any hands or anyone questions, we will screen share or answer or talk about whichever ones we need. So do that, and then just let me know as soon as you guys run into any questions or problems. You're also allowed to ask questions on what we talked about today or anything else if you have it. Just wanted to focus on labs if there's nothing else that you guys have going on.
So I got a quick question about you on your integration. I could be very wrong on this. It's been a while, but shouldn't 2x squared come out to be 2x3 divided by 3?
Did I mess something up? It's quite possible. Let's see. So I said, because we got 2x squared plus 3, and then I said, yeah, what did both of those, and where did x to the 5th come from? That is a good question. I did this example a while ago and then didn't update it. Yeah, because here I integrated it correctly, right?
Yes. Yeah.
So this is 2x to the 3rd over x to the 4th to the 4th. So yes, that should be, somehow my numbers, I'm going to blame some type of weird autocorrect on here. Let me check this. I'm willing, if anyone gets bored, and check that. 1.2 still seems like the right answer, so I'm guessing I integrated it correctly, but wrote it incorrectly here, but he's exactly right. That should be 0.75, and then that should be x cubed over what? It should be over this should be 2x cubed over 3, and then that should be minus x to the 4th over 4, correct? Does my math look right on that? Did I lose you? Does that look right, Brian?
Yes, sir.
Okay. I do not have my graphing calculator, but I will fix that up and edit that before I post these slides, and then I will see whether or not this answer is still correct. But my guess is that it is. But I will mute up and I will try to work that until someone else has some other question for you. But that is a good catch. Thank you.
sorry, I might be blind, but is the lab 3 supposed to be in the team's assignments?
Oh yeah, that is a good point. Someone pointed out to me earlier that I have not. So I need to make an assignment. I will do that as we speak right now. But in the meantime, anytime I am lazy and the labs are posted, but I haven't made an assignment yet, if you go to the all students team and you go to files and you go to class materials here and you go to labs, as the labs are finished and updated, all of the information is here. I just sometimes miss that they have already been posted and then do not create the assignment. So I have not created an assignment. So I will go create that assignment right now. But in the meantime, all the files you need to do it are right here. But let me go do that right now.
Senator Colonel Richards, for your last one, the integration, I believe on it's 1, not 1.2.
Excellent. All right. Thank you. I will update that and before I post it. So thank you for that catch. That is awesome. Thank you for checking my work.
Thanks, sir.
Okay, there. Now it should be assigned to you guys in there. I apologize for that coming in late. All right, and I will double check that later. Okay, we are coming to the end of today's time. So if anyone has any last minute questions, either shoot them now and I will stick around for a couple of minutes if there's something I can do. But otherwise, as always, we don't have class tomorrow, but I am available for later today as well as all of tomorrow. I'm off obviously on the weekends, but use the collaboration space. You guys have been doing well helping out. I try to monitor that to nudge people in the right way if you're not seeing the right answer in there. And like I said, if there is a video, I'm going to start making some more videos for the next labs and R. But if there's something specifically that you go, hey, I would love a video on this, just shoot me a message, because I would rather make videos that you guys want rather than videos that I think you want. So I'm actually thinking about setting up a channel just to suggest videos. So send me what you want, work on that, get any questions that you need answered. over to me on Lab 3 by tomorrow so that you can at least get a conceptual answer going into the weekend. And then when we come back next Monday, if you still got stuff, I will be available and reading everything that came in on the weekend. Other than that, that is all I've got right now. I will let you guys go and see you on Monday, if not earlier. Have a great weekend. Otherwise, I'll stick around for a few minutes if you got questions. Otherwise, I will see you then.